Good day everyone, my name is Anthony Nathaniel and I welcome you to the second episode, or rather to the first episode of this second course in mathematics on Global Education Zone, or GLED Zone for short. Now this second course is designed to be a follow-up from the first course which I did on mathematics for secondary school 1. That is mathematics for the first secondary school course. Now this is the mathematics for secondary school, and that is SS2. Now in this this first episode, I'm introducing this course, and also I'm using the same time to introduce and summarize all we covered in the previous course for SS1. So before you go to SS2, you have to pass through the senior secondary school 1 syllabus, right? So now that's why I'm staging this first episode to be both an introduction and a revision. Now in the previous course, we talked about concepts like number and numeration. We talked about algebraic processes. Here we talk about simultaneous equations. We talked about graphs. We talked about quadratic equations. We talked about various interesting topics. And if you don't understand any part of all these things I've mentioned, you can still go back to those episodes. They are all free to watch. All you need to do is just devote your time and attention to those videos. Now I'm glad you have made it to this second course, and this second course in mathematics is going to stage up from there, just as I introduced earlier. So, but in this revision, let's talk about what did we cover in the previous aspect. Today I might not do much of calculation, but I have decided that okay, that mathematics also is not just about calculation, but we also need to know how to understand the concept, the basics, and the fundamentals. Those terms, those terminologies. So we have what we call numbers, right? Numbers are from 1 to 10, 1 to 3, 4, 5, 6, 7, 8, 9, and 10. Now these numbers, they are having their own values. For number 1 has a value of 1, and numbers are represented by symbols. These symbols are used for representing the numbers. For 1, 2, 3, 4. When you write number 1, you can either write number 1 as O-N-E, or you can write it as 1 in mathematics. But in mathematical, we'll make use of the symbols for these numbers. So we'll make use of digit 1, digit 2, digit 3, digit 4 for number 4, digit 5 for number 5, and so on and so forth. And these numbers, they can be very large or they can be small, and we can perform operations on these numbers. So that is basically what mathematics is. Mathematics is simply the operations performed on mathematical symbols, and these mathematical symbols, they include numbers. Now these numbers, apart from numbers, we also have alphabets. Alphabets, they are often used to represent variables. Now these variables, alphabets from the first class of the alphabets from the first few alphabets, that is in 20th alphabet. Those letters, alphabets from the first few letters, they are used to represent symbols mostly, because even one of the episodes I did on the senior secondary school 1 course, where I talked about partial variation, you can notice that I represented my constants with A and B. Now in alphabets from the lower part of the alphabetical table, that's A to Z, they are often used for representing variables and unknowns. For example, when you make use of your X, your Y, your Z, your W, and so on and so forth, those are often used in simultaneous equations when X and Y are to be evaluated at the same time. So mathematics involves a lot of concepts, and these concepts, they are tied together by your basic mathematical processes. And I talked about basic mathematical processes. They are summarized into your steps for mathematics. For example, you have your board mass. Your board mass is the steps in which you perform calculation. Your brackets, your of, your division, your multiplication, your addition and subtraction. That is the board mass. Now this board mass is not the only steps. We also have other steps in advanced levels mathematics. We also make use of exponents. So exponents, we also include that in the step after your brackets. So that involves many other things we can do with these mathematical steps, and we can also understand mathematics better when we can understand and assimilate the steps. So now let's go on to the next part of number and numeration. We're talking about numbers and numeration now. So numbers and numeration is one of the 4 major aspects that I deal in this course. So this course is based on 4 major aspects: number and numeration, geometry and trigonometry, statistics, and then we have algebraic processes. Now we're starting from number and numeration. Now we have what we call place values. So place values are basically when you have your numbers, they are like the crowns, the values, let's say the weight, how what is the worth of each of those numbers in a group of numbers. So you have a digit, right? For example, let's say you have a digit 345.67. That's 345.67. This is a mathematical digit, and this is a number. This is a mixed number consisting of a whole part and a fractional part. Now, the fractional part of a number is the part that comes after the decimal point, and the whole part of a number is the part that comes before the decimal point. So, if I want to express, if we ask what's the whole part of this number, that's 345. What's the fractional part? That will be 0.67. When you add the whole part and the fractional part, you get the mixed value or the total value of that number. Now, we also have what we call place values. Place values are the worth that are placed on each of these numbers. Each of these numbers, they don't have equal worth, because each of them has the worth that we assign to it, so that we can use it to calculate and evaluate algebraic processes, just like addition, subtraction, multiplication, and division. In the right way. For example, this is the unit. This has a place value of a unit. So this 5 is a unit. Then this 4 is a tens, TENS. Then this 3 is a 100, HUNDRED. So and then any number that any digit that come after your decimal point always has a TH, place value TH after the place value. For example, this first number after the decimal point is a tenth, TENTH. So you shouldn't confuse it with this 4 that comes before the decimal point. This 4 is a tens. What is a tenth? Tens, tenth, tens, tenth. TENS and TENTH is a versus. They are not the same thing. Now then this 7, this last digit is a hundredth. HUNDRETH. So abbreviated HTH. And this is also abbreviated TTH. This is abbreviated U. This is abbreviated T. This is abbreviated 100. And even when you go further to larger numbers, you often have place values of your thousands, your tens of thousands, your hundreds of thousands, your millions, your billions, your quadrillions, your zillions, and so on and so forth. So now every simple number you can see in your digit always has its own place value. But these are the basic ones you can use for the numbers that have 3 whole values, 3 whole places, and 2 decimal places. Now that is how number and numerations work. So outside this, we also have when you perform algebraic processes on these symbols, on these numbers, like addition, multiplication, and division and subtraction. Now you can have quotient, and then you have remainder. When you perform division, when you perform addition, you can have a result. When you perform subtraction, you could have a negative number. So that is when you are subtracting a bigger number from a smaller number. So right, you are subtracting a bigger number from a smaller number. You can have a negative result when you do that. Then we also have when you divide a number by it, so when you divide a multiple of a number by that number, you get a whole result. For example, when you divide 28 by 7, you get 4, and your remainder will be 0. So your result, this 4 is your quotient, while your 0 is your remainder. So and most not all divisions can have 0 remainders. Some are non-zero remainders. Some, for example, if we divide 29 by 7, when I clean the 8 and put 9, I'll have a remainder of 1, because 7 in 29 is 8. Sorry, 7 in 29 is 4 times 28. Then you subtract that value, that's 28 from 29, will give a remainder of 1. So that is basically how division works. Apart from division, every other mathematical operation, they are all straightforward. And I've outlined each of these steps in each of my calculations and videos in the previous episode of crash course in mathematics for secondary school 1, senior secondary school 1, or SS1. So you can check those videos out again. So if you want to revise things up. And then we have prime factors. Prime numbers are numbers that can only be divided by 1 and themselves. So examples of prime numbers are digits 2, 3, 5. So you can see that each of these numbers I'm listing here, they cannot be divided by any other number except 1 and themselves. 2 can only be divided by 1 and 2. 3 can only be divided by 1 and 3. 5, 1 and 5, and so on. So for every prime numbers, you should always know that automatically they can only be divided by 1 and themselves. And they are kind of the numbers that have been kind of like an integral to mathematicians, but they have a special quality, and this is their quality. Now, these prime numbers, when you multiply prime numbers together, they are called the prime factors. When you have them when you multiply them to get a number, those numbers that you multiply, they are called prime factors. For example, if I have a number 30, now this will be the prime factors of number 30. Why? Because when you multiply 2 by 3, you get 6. 6 by 5, you get 30. So when you multiply your prime factors together and they give you a whole number, that is given as the prime factorization. So the prime factorization of 30 will give 2 times 3 times 5. Then the multiplication of 2 times 3 times 5 will still give you your initial value of 30. So whenever you are asked to express a number as its prime factors, what you do is you divide a number down to the prime factors that it is composed of, and then you multiply those prime numbers the way they are. That's how it is. So that is called the expression as a product of its prime. So when, for example, when we express 40 as a product of its prime, that will be 2 times 2 times 2 times 5. When you multiply 2 times 2 times 2 times 5, you still get back 40. So if they ask you to express as a product of its prime in index form, so you condense that to 2 in 3 places, we give 2 raised power 3, 2 raised power 3 times 5. So instead of 2 times 2 times 2 times 5, when it asks in index form, you just write 2 raised power 3 times 5. So that is how mathematical notations work in different ways. Now we also have highest common factors and lowest common multiple. Now this HCF and LCM, I was also taught in secondary school, in junior school, and then primary school. So now this HCF and LCM, they don't usually give you the definition of these terms. They don't usually tell you what they mean. But these things, they have their definitions and have their significances. So in mathematics, it's not just about juggling numbers and algebraic and logical equations. Mathematics also has an algorithm. Mathematics also has its own steps. It also has its explanations. It has its terminologies. So that's what I'm doing in this introductory video, because I noticed that in the previous videos I focus on calculations. So now today in this episode, I'm devoting it not to calculations but to giving out a basic and fundamental breakdown of every terminology you might want to be coming across in these for subsequent videos for this channel. Now we have common factors. The common factors are the factors of more numbers. Common factors are those numbers that can be divided. That can go into 2 or more numbers. For example, if we have 10 and 20, the common factors of 10 and 20 is that number that can divide 10 and can also divide 20. For example, when we have 5 can divide 10, because 10 divided by 5 is 2, 20 divided by 5 is 2. 10 divided by 5 is 2, 20 divided by 5 is 4. Now that 5 is a common factor. Why? Because it can go in 10 and it can also go in 20. So when a number that can go in 2 or more numbers, it's called a common factor of that number. That's how common factor works. Next we have a highest common factor of a number. What is the HCF? The highest common factor, it is the factor that is the highest. That's the common factor that is the highest, simply. So if we are looking for the highest common factor of 10 and 20 now, we know that 5 is a common factor, right? But is it the highest common factor? No, because it is not the highest number that can go in both 10 and 20. Now there's a simple system for looking for HCF. Just draw a simple table like this, and what are your numbers? 10 and 20. Now you begin to divide. One we use 5. 5 and 10 is 2. 5 and 20 is 4. So what else can go in 2 and 4? Let's use 2. 2 can go in 2, 1. 2 can go in 4, 2. So what else can go in 1 and 2? No, nothing, because 2 is the prime factor, so nothing else can go. Now we have 5 and 2. We multiply these numbers together. That will give 10. So 10 is the highest common factor. So this HCF, also it's abbreviated HCF, is the highest common factor. It's simply that number. That's the simple definition of this terminology. It is that number that is the highest number that can go into 2 or more numbers. Simple. So we are just messing around with numbers, right? Mathematics, we just mess around with numbers and numerations. So that's fine, because mathematics is kind of like a universal language. So now this 10 will be the HCF of 10 and 20. Now apart from HCF, we also have lowest common multiple. Now lowest common multiple is not just a ununderstandable jargon and whatever. So it's abbreviated LCM, but it also has its definition. LCM, lowest common multiple, is the lowest multiple that is common to 2 or more numbers. So for example, it is that lowest number that can be divided by 2 or more numbers. For example, if we're using 10 and 20 now, what is the LCM of 10 and 20? Will be the lowest number that can be divided by both 10 and 20. I repeat, the lowest number that can be divided by both 10 and 20. So for example, if we use the same table this time around, we will clean this up and then we'll divide this to the lowest, and all the last digits for the last values for our columns will be 1. So for example, we have a value of 1 for this first column, we have a value of 2 for this second column. So we are not done dividing. Let's still break that 2 down. 2 in 1, we'll still write the 1. when you have a value of 1, you keep putting 1 in the subsequent values for the column. So but when you have 2, you break it down to 1. Now we have both as 1, so we can relax. So and then we multiply everything on this first column. That will be 5 times 2 times 2, that's 20. So we have a value of 20 as our lowest common multiple. So that means this is the lowest number that can be divided by both 10 and 20. So you can also see that 40 can be divided by 10 and 20, but it is not the lowest common multiple. You understand? So that's the difference between the lowest common multiple and the common multiples. So their common multiples are infinite. There are a lot of multiples for numbers, but we are in mathematics, we are specifically concerned with the highest common factors, the lowest common multiples. So that is just the analogy of this. Then we also have the different forms you can express your answers. So you can see that in the previous episode, in the previous course, I was dealing with when I was solving questions on the board, I used to give my answers either as fractions or as decimals or as mixed fractions. Now there are different ways you can express your answer in mathematics. You can express your answer in fractions or decimals. A fraction is basically when you express a number as a quotient of two numbers. Now for example, if we have 13, you can express 13 as 26 over 2. So you can, this is as a whole number and as a fraction. So when you cut down, when you break a fraction down, you should get a particular number, and that number can also be converted back to your fraction. And then when you have a number which is not whole, you can express it as a decimal or as a mixed fraction. For example, let's say we have 5 over 8. Now this 5 over 8 is a fraction, right? Now when we want to express this in another form, we can express it as a decimal. So we can subsequently be dividing repeatedly. We will repeatedly divide the numerator by the denominator to get an answer, which will be our result. So when we keep dividing, we should get 0.625 here. That should be the answer here if you divide repeatedly. So based on the method you want to choose. So for example, one method of dividing to get this answer is you just make a table like this. Put your numerator inside the table, put your denominator outside. So 8 in 5, how many 8s can you see in 5? You can't see any 8 in 5, so you add 0. So if you can't divide the number, you put 0 as a result above the table and put a point. Now you put another corresponding 0 inside the number in this table. Then 8 in 50 now, how many 8s can you see in 50? You can see 8 you can see 6 8s in 50 because 8 times 6 gives 48, just below 50. Now you look for that multiple of 8 that will give 50, that will give a number just below 50. So that's 48. So that will be 6 times 8 will give 48, which is just below 50. Let's write it down. So we have 20 as a result. So 50 minus 48 will give 22. Now because 8 cannot go in 2, we add a 0. That will be 20. 8 in 20 will give 8 times 2 16. So 16 is that number that is just below 20. 16. When we subtract 16 from 20, we get 4. 8 in 4 is not possible, so we still add a corresponding 0, and then 8 in 40 is 5. So now 8 times 5 is 40. So we can see that we've directly hit the bullseye because we've gotten 40 and there's no remainder. So when you get to a place where you cannot get any remainder from your division, you record a value of you record a value, stop, and you record your value. That's 0.625. But not always, because some fractions, they keep giving a repeated decimal. So in these cases, you can just stop in the required number of significant figures or required number of decimal places. For example, in this question, if I ask you this question and I gave this as a classwork for you, and I ask you to give me this answer to 2 decimal places. So what you do is you just go to you check the first 2 numbers that are after the decimal point. This is 6 and 2. Now this 6 and 2, you record them down, and then the number before them, that is this 5, you are going to round that number either up or down. So if the number is 5 and above, you round it up, but otherwise you round it down. So this is 5, this is up to 5 and above, we are going to round it up to, you round it up to 1. So you add it to the last digit. So that's 6, that's 2, that will be 0.63. So in other words, you are rounding 0.625 to 0.63. But if you add 0.624, you are going to round it down. That will still be 0.62. But since the last digit is up to 5, that's 625. So we are going to round that 5 up and add it to the number before it. That's 0.62 plus 1. That's 0.63. That's how that, and this simple process is known as rounding off. So this is how to just round off numbers and values, and this is how it works. Now Moving on, we have mixed fraction. There are different ways you can express mixed fractions. And in fraction, whenever you have a numerator that is greater than your denominator, you can always express it as a mixed fraction. For example, if I inverted this 8/5. When you invert a fraction like this, you have gotten the inverse. So the inverse of 5/8 is 8/5. So you that's just in case you've not come across that process before. Now, when you want to express 8/5 in mixed fraction, how many times can the denominator go in the numerator? Once, right? So you can see only 1 5 in 8, and then what is your remainder? That's 3. When you subtract 5 from 8, you get a remainder of 3. Then you divide by your the denominator once again. That will be one whole number 3/5. So this is how to express in mixed fraction. So this is for those of you that have understood these concepts. You can also move on to the next section of these videos. So there are a lot of things I'll be covering here. So just make sure you focus and gain as much as possible. So then we have reciprocal. So that's what I just talked about. The reciprocal of 5/8 is 8/5. The reciprocal of 1/2 is 2/1. And in general, whenever you have any number, the reciprocal of that number is 1 over the number. That is the multiplicative inverse. So for example, the reciprocal is also known as the multiplicative inverse. For example, if you have a digit of 5, now the reciprocal of 5 will be 1/5. So just 1 over that number, and it's represented as that number raised to the power of -1. That is reciprocal. You can see the application of reciprocal in various different places in mathematics. Just as when you want to simplify numbers, you can make use of knowledge of reciprocals to invert them. For example, if we are saying 8 divided by 1/2, so you make use of knowledge of reciprocals, because whenever you divide, division is just like 1 over the number, and division is basically the reciprocal of a number. So whenever you can multiply by that number by 2. So 8 divided by 1/2 is still the same thing as 8 times 2, because when you divide by the reciprocal of a number, it's the same thing as multiplying by that number. And when you multiply by a number, it's the same thing as dividing by the reciprocal of that number. So these are just the simple concepts expressed in terminologies, in words, so that you can understand. Because it's not always that mathematics should be about calculation. So at times, mathematics can also be about things like this, talking about the algorithm, these simple steps to getting all those jargon of all those numbers, alphabet, in variables and constants, all those jargons. So they didn't just fall from the sky. They are concepts though, but even as they are concepts, even as they are kind of incorporeal, they are still having some values, and they are still having some rules, some terminologies, and that's what I'm trying to explain now. So now let's move on. So we have you can also express your values as percentages. So but anytime you are converting to a percentage, you multiply by 100. So that is how to convert to percentage. For example, if we were to express this as a percentage, we multiply by 100. That would give us 62.5. Is 2.5%. So 0.65 multiplied by 100 will give 62.5%. That's how to express as percentages. Now we also have number lines. So number lines basically deal with when you have a line containing the numbers. So in your number line, you have your 0 is your middle point, and then your remaining digits are your to the left of your 0 is your negative number, and to the right of your 0 is your positive numbers. For example, on a number line, you can have 0 as this is just a straight line, and then you can have 0 at the midpoint. Then to the left, you will have a -1, because these are the numbers that are directly after 0 in decreasing order of magnitude. So -1 is greater than -2, is greater than -3, is greater than -4, so on and so forth. So the greater a negative number is, the lesser it is. So the greater a negative number is, the lesser it is. So it's kind of like an inverse relationship between the value of a negative number and its actual size. But in positive numbers, it is a direct relationship. So the greater a positive number, the greater it is. 0, 1, 2, 3, 4, so on and so forth. These are just the concepts of number line. So for example, you can be asked to add or subtract. So there's one simple logic in number lines. Whenever you add, you move to the right. Or whenever you subtract, you move to the left. For example, if we have a number, if we have to say what is 2 minus 7, what's the value of 2 minus 7? So you start from your first number. So your first number is 2. You draw a notch, a 0 or a notch on top of that 2, and then you move 7 places to the left, because we are subtracting. So whenever you are subtracting, you move to the left of your number line. So that will be 2 to the left, 7 places. The first place is 1, 2, 3, 4, 5, 6, 7. So if you extend this number line, you still have -5. That means when we go 7 places to the left, we land at -5. So -5 is our destination and is our corresponding result for that algebraic process. So 2 minus 7 is equals -5. So you can always represent addition and subtraction on your number line. So it depending on what you are asked to do and in your examinations. So then number lines, they are very simple to grasp. That's just the theory. And then we have integers. So integers is a positive or negative whole number. So an integer is simply a positive or negative whole number. And integers are those numbers that are represented on this number line. So on this number line that you see here, what we have on this number line, we have integers, and these integers are arranged from positive numbers like 1, 2, 3, 4, 5 down to infinity. So because of that, you always have an arrow on your number line. So this arrow pointing in both directions. So that shows that it goes on. Even infinity is not a definite number. It goes on. We don't know whether infinity always has a definite number. Infinity could be a range of numbers. Infinity could be an infinite number. Who knows? Mathematicians have not yet determined that, but probably the subsequent generation will do that. Now moving on, we also have when we go to the negative number, we have minus infinity. So minus infinity is an extremely small number. You might have thought that 0 is the smallest number, right? No. In mathematics, minus infinity is the smallest number and infinity is the greatest number. So that's how we reason in mathematics. We are just meddling with concepts and messing around, but it produces reasonable results. Now, when rounding off, we also round off, and that is rounding off numbers that are 5 and above to 1, rounding off otherwise to 0. So we also have in the previous course, I also talked about binary numbers and bases. So we have base 2, base 3, base 4. How do you perform calculations in bases? So this is very simple, and whenever you are performing calculations in bases, whenever you are asked to expand the base, all you need to do is you write that value of the base and you multiply by the base raised to the power of that value. So for example, when you are looking for 11 base 2, 11 base 2, so all you need to do is the place value of this first one is 0, the place value of the second one is 1. So you just multiply the number 1 times the base is 2 raised to the power of 1, then plus 1 times 2 raised to the power of 0. So because the reason why you are multiplying by 2 raised to the power 1 and 2 raised to the power 0 is because the base value of these two digits are 1 and 0 respectively. So you multiply the number by the base raised to the power of that number. So that's how you expand. And when you expand, you can always convert to base 10. So whenever you expand like this and you evaluate, you subsequently get an answer in base 10. So any base can always be converted to base 10 in this using this simple method and algorithm. Now we also talked about finally after all said and done, I also talked about modular arithmetic. Now modular arithmetic was the final video of my SS1 course in this channel, and it was a very interesting topic. So check it out if you haven't checked it out. Just search in this channel homepage, which you will see the video. So that was what I used to conclude the course. And then moving on, after what I covered in number and numeration, that was for number and numeration. Let's go to algebraic processes. Now this is just in case you are just joining us, or maybe you have lost the big picture. This video is simply meant to be a revision and a guide through mathematics. And this time around, I've designed the revision not just to be a calculation, but just to also be an explanation of the major terminologies, the concept in mathematics. So we can't just keep calculating every day without understanding what we are writing. So this is kind of like going to be a pace setter for each of the corresponding and the subsequent videos that I will be uploading in this course. Now moving on, we have algebraic processes. Algebraic processes is kind of like my favorite part of mathematics because it takes the bulk of our work, even in school. Because for you to be watching this video, you should be interested in school and you should have been attending school, or maybe you just want to start. Who knows? So now in school, algebraic processes it carries the major part of mathematical calculations, because algebraic processes involve simplification. All those mathematics. When you talk about calculation, when you talk about mathematics, you know that your brain will tell you that okay, we're talking about calculation, right? But in mathematics, the bulk of those calculations is hinged beneath your algebraic processes, because your algebraic processes, they involve a lot of calculation and simplifications. So and then you have all those steps, and it's even in your algebraic processes that will make use of your board mass, which is your bracket of division, multiplication, addition, and subtraction. So that board mass is the order of algebraic processes that will be performed on numbers and unknowns and variables. Now algebraic processes will make use of different symbols for denotations. We make use of letters. Letters are used for constants, and then we make letters are also used for constants, and then we have numbers. Numbers are majorly used for constants. So you can also have a mix up. You can have letters and numbers used for constants. They can be mixed up together. For example, when I have 3a, I can say a is a constant. You understand? So that's a. This is a term, and this term is a constant term. But if I have something like 3x, this will be a variable term, because any letter from the last few letters of the alphabet will be a variable, while any letter from the first few alphabets like A, B, C, D are often represented for constants, while X, Y, Z are often for variables. So just in case if you see any questions and then you are having issues, because most students have issues with this kind of concept, because most of the time whenever you have questions in your examinations, you mostly not have the instructions directly and easily tabled out for you. So whenever you finally get the question, you might be wondering that okay, what am I dealing with? For example, let me tell you a story. When I was in junior secondary school, I was given a question in my examination which was C is equals to A plus B K. I was like, okay, wow, like I was taught everything. They taught me everything. They taught me all the basics. But the thing is, I was having a problem in that I was not able to differentiate between the constants and the variables, because I was not able to understand that these first few letters of the alphabet represent constants, while these last few letters like K, L, M, N, O, P, Q, S, T, U, V, W, X, Y, Z, they are often for variables. So most of the time we often make this kind of mistake, and I remember that I missed that question, but later I was able to write the exam and I got it. So in this case, this is a variable. This capital letter C is your subject. So whenever you are expressing in algebra, you have two different ways to express in mathematical algebra. So you can express in terms of your expressions, and express in terms of your equations. Now anytime your expression always has an equal sign or an equivalent sign, it's called an equation. Now an equation, this is an equal sign. These two and then when there are three, it's an equivalent sign. So equivalent sign, we don't use them much in algebra, but we use them in trigonometry, geometry, and other parts of mathematics, and even calculus, so as to represent the fact that two different the left hand side and the right hand side, they are not just equal, but they have each term is corresponding. So that's what's known as equivalence. So for example, when you deal with partial fraction, there's a hidden equivalence there. So I understand that you might not have gotten to the stage of understanding partial fractions, but if you also wish to understand, my subsequent videos will also cover that too. Now let's move on. Now this is the subject of the equation. The subject of the equation is often the sole term, the only term. The subject of the equation is like is like a lone wolf on the left hand side or the right hand side of the equation. Nothing shares the side with it. It's just a greedy and self-centered term, and it just carries the whole parts of the outside, but the remaining terms of the equations are on the opposite side. For example, if the subject of the equation is on the left hand side, then you have nothing with it apart from its coefficient, and which is often 1. So and then if you have another coefficient with it, you often strive to delete that coefficient. For example, if you have a coefficient of x here, if you have a coefficient of xc, now you want to delete that coefficient, because you want your subject of the equations always wants to be at the limelight. It doesn't want to share its glory with every other term in the equations. So it's always alone. Anytime you see a term alone like this in the left hand side or the right hand side, it's the subject. Then the remaining are the objects of the equation, but we don't often call them objects, we just call them terms. Now this equation, you are often solving for the subject, and then you can use different methods for like substitution, like simultaneous equations, eliminations, and so on and so forth. You can use different methods to make sure you can get the final answer, and your result in mathematics is like your goal. It's like the end that justifies the means, and the means is just all those laborious hours of calculations and adding and subtracting and laborious. Now mathematics is even though it might sound a little bit difficult, I'm actually stating all that. Actually, I think mathematics is kind of like easily one of the best subjects in the universe. I'm not kidding. Now, in algebraic processes, we have these expressions, and then they are connected together by an equation or equality sign, right? Now, you are often asked to solve for the unknown. Your unknown is often the subject, and if it's not the subject, you change the order of the equation or change the subject of the equation to look for the unknown. For example, if we change our priorities now and I say, okay, now I'm leaving C, I'm done with C, and I'm using K. Now this K is a variable. They are both variables. K and C are variables. But now if I say I'm done with C and I'm changing over to K, it's K for now and K. Now I will have to make K the subject of the equation, because K, I can't look for K when it's not in the determinant. K won't answer me. If I'm looking for K, K won't be found, because K won't want to meet me. He won't want to see me because I have not given him his priority. So you have to make the term the priority, so that before you can see it and before you can look for its values in an equation. So before you do that, this is the simple step. All you need to do is you are going to delete every other term and coefficients from that subject. So I want to make K the subject now. So now you can see this A is added to BK. So whenever you are adding to a whenever there's a connection between your term, your subject term, and other terms, you are going to delete those terms by using the opposite or inverse operations. For the inverse of addition is subtraction, right? So let's just say, let's subtract A from both sides. That will be C minus A on the left hand side equals A plus B K minus A. So so the reason why we do the same thing to both sides is that for mathematics, there's always equality. Mathematics is kind of like easily the best law system, because mathematics is very simple and very analogous to law, because everything you do to the left hand side must always be done to the right hand side. So here we have A minus A gives 0. That's C minus A equals BK. And the last step to do is, now there's this B, and this B is like a clingy coefficient to K, and we don't want B clinging to our coefficient, so we just delete it and we divide both sides by that coefficient. So anytime you want to delete your coefficient, you divide both sides, it cancels out. So C minus A over B equals K. So now K is now satisfied because it's now the subject, which is the lone term in the right hand side. So you can now simply substitute your values for your left hand side to get your corresponding values of K. Now, for example, when I say substitution, that's another term, another process in algebra. So for example, if we are going to substitute now and we have C is 7, if C is 7 and A is 1 and B is 2, so you can simply substitute. So substitution involves you are going to replace that your letters by your numbers. So substitution in mathematics is simply the process of replacing your letters by your numbers, because now we have C is equal to 7. So instead of writing C, you replace C with 7. So write 7 minus, now we have A is equal to 1. So instead of writing A, you replace A with what? 1 divided by B is equal to 2. Instead of writing B again, you replace B by 2. So 7 minus 1 over 2 equals K. So you can see 7 minus 1 is 6 over 2 equals K. 6 divided by 2 is 3 equals K. So 3 equals K, and finally we've successfully evaluated the value for K. Hurray! Now that is just how algebra works. Very simple. And then you can not just have equations, but you can also have inequalities. So inequalities involve your greater than sign or your lesser than sign. Now your greater than or lesser than sign, they are just representing regions. They are not definite. So if a region is definite in mathematics, it's represented by an equation. But if it's not definite, if it's just a like blurry and if it's not in black and white, if there are shades of gray, you can know that is definitely an inequality. Now inequality could be greater sign. You can use the greater sign. When the first number is greater than the second, you can use the lesser sign. When the first is lesser than the second, you can use the greater than or equals to. When the first is greater than or equals the second, you can also use the lesser than or equals to. So when the first is lesser than or equals to the second. For example, if I say the length of this video is lesser than or equals to 1 hour, so what I mean is that if it is 1 hour, I'm also correct. But if it is lesser than 1 hour, if it's 38 minutes, it's also correct. For example, this at this point in time you are viewing 39 minutes of this video. So that's just what mathematics is all about. Numbers, calculations, and very simple, kind of day-to-day life. So very practical. Now inequalities, these are the signs. And then lastly, we also have an inequality sign. No, inequality has its own eponymous sign. So this eponymous sign is equals to with a slash. So inequality is telling you that hey, I'm an inequality. So this is it. So if the first sign is not equal to the second, you can just say, if the first term is unequal to the second, just say, use this inequality sign, just an equals with a slash. Every term in mathematics, every concept always has its symbols. Now, equations and inequalities, they are just the two things we will deal with, and expressions also. We deal with expressions, we deal with equations, we deal with inequalities in algebra, and all these algebraic processes we've done with the basics. And then we also have, when we talk about equations, you can extrapolate a graph from an equation and vice versa. So there's a specific video where I dealt with this, where I extrapolated a graph from quadratic equation, I extrapolated a graph from linear equation, and then did the opposite, the reverse operation. So you can check that video in the course for mathematics for SS1. There are also there are a lot of videos in that course. We always recommend that if you have not watched every video in that course, you should always try that, because they are, even if you've known them, they are just like a simple revision that can help you go back to those basics and help you polish things through. Now, thank you for still following this video, and don't forget to like, to share, and subscribe, so that you can encourage me to keep producing things like this, so as to advance the education sector of West Africa and Nigeria. So moving on, we have graphs. So graphs are basically, they are mostly represented on Cartesian coordinates. So, and it's also known as an Euclidean plane, and this Euclidean plane, they are often used to represent your dependent and independent variable. Now in mathematics, you often see your dependent variable represented as y and your independent as x. Now this simply means that your y will be on your vertical axis and your x will be on your horizontal axis. It's just based on convention. There are no hard and fast rules. So what this means is that your y your y values will range from top to bottom, and your x values will range from left to right. So, and then your left values for x are your negative values, negative x values. Your right values is your positive values. So in mathematics, we just follow the convention. So because your right hand is often the normal hand used by you, and because a lot of people use the right hand, so we just say that the right hand is the positive side, and then the left hand is the positive side. So I just assume that's how it is. And then because your upper is often positive and your lower is often used to represent a negative, so the upper values of y will often be positive, will always be positive, and your lower values of y will always be negative. So even when you make use of other conventions and other system in mathematics, for example, your numbers are not real. So we have numbers like I and j. When you go in further mathematical classes, we'll deal with I and j numbers. I and j, these are also your imaginary numbers. So even at that, you often still make use of these similar conventions, your positive, negative, and these are just how they work. So if you grasp them, you won't have anything to struggle with in subsequent videos and your education. Now, when we have these expressions and equations, we can expand and factorize them. For more information about this process, you can still check that SS1 course for mathematics. It's a lot of all these things I'm saying, they are all ensconced in that course. So now I guess we have gone through the algebra, and then let's move on to another part, so which is geometry. Now geometry is a lot of fun. When I was in secondary school, I enjoyed geometry a lot, because it was just kind of like just relationship between mathematics and space. So for those of you who enjoy physical activities, you will know that when you kick a ball a distance, your distance can be measured in meters, and then your distance can also be calculated in terms of coordinates. So these coordinates and all these messy Cartesian principles, they are all geometry and mensuration. Now geometry, ignoring this bogus name, it's simply dealing with shapes and area. So for example, your cuboid is a shape. Your cuboid is that shape, the shape of your textbook, the shape of your phone is a cuboid, but just that it has a slim height. So, and then we also have the shape of a carton of biscuits, the shape of a packet of let's say sugar, a packet of anything that is in a box. Anything that is a box is a cuboid. So take it from me, anything that is a box is a cuboid, no matter what it is. So a box of sugar, a box of shoes, a box of gifts, a box of cake, a box of whatever, a box of whatever is a cuboid. Now there are different types of cuboids. So these cuboids, generally they are boxes, right? So but when that box has all its sides, all its dimensions equal, it's called a cube. So a cube is a special type of cuboid with all its dimensions equal. So if you have any mathematics textbook, or you just look around your house, so even that sugar, the sugar you use in your tea or your coffee this morning, when you drank tea or coffee this morning, that's if you did. Now that cube of sugar is in the geometric shape of a cube, and it has all its sides equal. So apart from cube, we also have cylinders. That is the shape of this marker. When I remove this head, we have this marker as a cylinder because it has a round height, and then it has a flat base and flat top. Now I talked about this in the previous episode also. We also have the triangular prisms, we have cones, we have square base prisms, we have spheres. Now spheres very applicable in even our world is a sphere. Our world, the earth, is a sphere, but it's a special type of sphere known as a geoid. Now these are just geographic principles and all the rest that you can also get and understand when you understand geometry from mathematics. Now we also have different properties of shapes. For example, let's talk about the properties of a three-dimensional shape. A three-dimensional shape like a cylinder. This is how a cylinder looks. It looks like a barrel. Now in this cylinder we have what is known as face. So a face is that flat surface that you can touch. This is a face. We have this round face, and then we have the top face, we have the bottom face. They are all faces. Then after faces, we also have edges. Edges is the intersection or the interface between the face and another face. For example, when we talk about the interface between this face and this face, there's an edge. Just this line you can see. So in mathematics, we always draw the edges, so they look optically appealing to our eyes. So this edge, this round line is an edge. This round bottom line is also an edge. Now those edges, they are often used to represent the boundary of a face with another face. Then we also have vertices. A vertex is used with them when you have cuboids. So for example, this is called a cuboid. What I was talking about earlier. That cube of sugar is also a special type of cuboid. Now these cuboids, these edges, this point where three of these lines meet, they are vertices. So they are like the terminations of those faces. These are vertices. So we have faces, vertices, and edges. So you can also be asked to calculate the faces. For example, in this cylinder we have the top face, bottom face, and then the uniform cross section face. Now there are three faces: 1, 2, 3. For this cuboid, we have how many faces? We have the top face, bottom face, left face, right face, the back face, the front face. Those are 1, 2, 3, 4, 5, 6. There are 6 faces for a cuboid. So for example, that's how it is. And even you can also extrapolate and go advanced and into this concept. Even in advanced science concept, we make use of this whenever I want to talk about material science, and they also talk about the phase and the shape of molecules. So if you are a science student, you will understand, but if you don't understand, it's all right. So I'm just trying to express the relationship and association with everything I'm teaching. So let's move on. Now these properties of three-dimensional shapes, these are all them. And then we also have the face, we also have the edges. These edges, we could count the edges. So this is 1 edge, this is 2 edge, 3 edge, 4 edge, 5 edge, 6, 7, 8, 9, 10, 11, 12. There are 12 edges. So these edges are basically the boundary between faces. So if you know what a face is, you will definitely know what an edge is, because when I say if an edge is the boundary between faces, you can say that this is one face, this is another face. So what's the boundary? This is the boundary. So this is an edge. So if you don't know what an edge is, you can also always redefine that definition and use it to get what an edge is. So that's why I'm doing this video, so that if you can listen carefully, you can always be able to understand, and then with the definitions you've gained, you'll be able to go back into your book, go back into the exam hall and trash that exam and just deal with it. So next we have different other concepts. So we also have vertices. So these vertices, they are the end determination points. 1, 2, 3, 4, 5, 6, 7, 8. They are just 8 vertices. So these vertices, they are just the places where there are points. Vertices are points where those edges terminate. So you can see that there are 8 points in this shape. Now that is majorly what we'll be dealing with for geometry. But if you are looking for further information and for the area of and surface area and volume of shapes, I've also done all that in a previous video in your SS1 course for this channel. So we also have cube. The surface area for a cube is 6s squared. The volume of a cube is s cubed. The surface area of a cuboid is 2 open bracket lb plus bh plus lh close bracket. So this where the l is the length, the breadth is the b, and then the h is the height. So we also have the volume of a cube is lbh, length times breadth times height. So and then on and on and on. There are different other concepts we'll be dealing with in geometry and mensuration. So now Mensuration is basically dealing with the measuring of the volume and area of all these geometric shape. So geometry and mensuration, they go hand in hand. So then we also have, in mensuration and geometry, we also deal with angles. We also deal with trigonometric ratios, but that was specifically in trigonometry. Let's not delve there. But when you have angles, there are basically rules and theorems concerning angles. For example, we have different types of angles. Acute angles are less than 90. Obtuse angles are between 90 and 180. Reflex angles are between 180 and 360. Right angles are 90 degrees exactly, and then straight lines are 180 exactly. So you can use this knowledge, because whenever you have a group of angles adding together to form at a point, you can know that point, there's a circle around that point, and that point is the sum of angles around that point will be 360. So the sum of angles around a point is 360. So that knowledge, you can use it to simplify any question you are given in mathematics. But just know that in a point we have 360 degrees. Now we also have, in a straight line we have 180 degrees. So if you have angles on a straight line, and then you are given an unknown angle, you can always know that when you add both, you get 180. And then when you do that, you have gotten an equation, and that equation is what will lead to your answer. For example, what I'm just saying is that this, when you have a straight line like this, and then you have these two angles, angle A and B, and let's assume you are given angle A as 70, and then you don't know what angle B is. So you can simply use the knowledge that the sum of these two angles will be 180. So when you add 70 plus B, you get 180. So you've simply gotten an equation with that knowledge, and then you can simply solve for B by moving 70 to the right hand side. 180 minus 70, or rather by subtracting 70 from both sides, you get B is equals to 110 degrees. So this B here, this unknown angle will be 110 degrees. So that is simply how this works. Very simple and easy to understand. So we also have angles of elevations and depressions. So you know that the thing is, angles of elevations, they are just the angle of a line that a line makes with the horizontal whenever you're looking upwards. So your line of sight, the angle your line of sight makes with the horizontal, that's an angle of elevation. And we also have the angle of depression when I'm looking down. So the angle my line of sight makes with the horizontal, that's an angle of depression. So angle of depression and angle of elevation, they are often equal because they are both in reference to the horizontal, but most of the time you will often be dealing with either in an equation. So we also have the bearing and direction. Bearing and direction is often measured clockwise or anti-clockwise. So we often measure our bearing anti-clockwise, always in mathematics. So but you can also do otherwise. It depends on what you're asked to do in your question. So moving on to the last part of this video. So let's not forget about the trigonometric ratios, which I've talked about in great detail in previous episodes. So trigonometric ratios include your sine, opposite divided by your hypotenuse, your cos, adjacent divided by your hypotenuse, then your tan, your opposite divided by your adjacent. So those are just the concepts you should be able to understand by this time. So lastly, let's talk about your statistics and probability before we end this video, which is the last little place we'll be talking about here. And statistics and probability is one of the widely most applied concepts in mathematics, because statistics involve your calculation of things, because human beings, we are billions and billions of human beings in the world. So for example, you might want to know how many human beings are there in the world, how many people are black, how many people are white. That's all about statistics. How many people watch this video, how many people subscribe to this channel, that's statistics. So I take the statistics and I call it my analytics. So depending on, no matter whatever bogus name you want to call it, statistics originated from mathematics, and it involves your calculations and performing operations on group of data. So this data here you have, they are often calculated, and they are often you get different terminologies from them, and these terminologies include your mean, your median, and your mode. And your mean is also your average. So your average of your data, for example, if you have a collection of data and you want to get the average, you just sum the number of data divided by the number of data, the sum of data divided by the number of data. So that's simple. So the average of three things. Let's say if we are looking for the average of 7, 5, and 8, you just add 7, 5, and 8. Just 7 plus 5 plus 8. So divided by, what's the number of data? There are 3 data here, so that's 3. That's the number of data here. So the sum of data divided by the number of data, that would be 20 over 3. So you get your mean. Your mean will become 6 whole number 2 over 3, or 6.66. So, or 6.67 when you approximate the third decimal place. Now that is just a simple demonstration of your mean, and they are all known as your measures of central tendency. You have your median, which is the middle data. So the middle data here will be our 5. Then you have your modal data, which is the most occurring data. So for in the case of large data, not just 3 numbers in this case, but in sometimes when you are dealing with billions and billions of human beings, for example, let's say for YouTube now, YouTube deals with billions and billions of, so maybe that should be millions, who knows? But I just felt like saying billions. Who knows? Might get to billions. Now YouTube deals with a lot of subscribers and a lot of channels. So this, when they want to calculate the data and they want to make use of and they want to analyze that data, so they will make use of modal. They could make use of mean, they could make use of median to just generalize and centralize the data. So those are also known as measures of central tendency. But if otherwise you want to look for the dispersion of data, you make use of measures of dispersion. So I will also talk about this concept in intricate detail as the time comes for the subsequent videos in this channel, but let's just deal with the introduction and the basics of this concept. Now that was what I was dealing with, that was what I wanted to deal with, and that is what I have dealt with in this video. And I congratulate you all for being patient with me till the end of this video. So now this is the end, and I hope to see you in the next episode. So thank you for watching.